morning. Thank you for coming. And you probably don't know much about what a neuropsychologist is, and I was trying to explain to the people up front. I work with patients in a neurosurgery clinic, and I do assessments of cognition in patients that are getting assessed for various brain disorders and diseases, traumatic brain injury, epilepsy, tumors. And I spend about half my time in clinic working with patients. The other half of my time I spend doing research. And I like to research some crazy, wacky things like creativity, and have been funded for the last number of years to study creative cognition. And this is what I'd like to share with you today, is some ideas about what we think we're trying to understand, or what we are understanding with creativity. So this is the structure of my talk. If you haven't seen Prezi before, you're going to be in for a bit of a ride. And instead of giving you the take-home points at the end of the talk, I'm going to give them right at the beginning. So if you're ready to write, most people leave these for the end. These are the 5 key habits of highly creative people. So just to start out, they put out a lot of ideas. Creative people, they're putting out failures as well as successes. And this is perhaps the prototypical example of that creative concept is Pablo Picasso. And they're currently cataloging his productivity, and he has well over 25,000 individual pieces of art that he put out over the course of his lifetime. Sketches and drawings and pieces of metal that he worked with. And some led up to his masterpiece Guernica, which you can see him working with the bull, for example, dozens and dozens of drawings of bulls to get there. But I had the good or misfortune, I guess, of going to a museum and seeing works of Picasso and his drawings on bulls. And this is something that a child could do. This is not particularly great art, but it is working with ideas. It is this visualization of what could be out in the world. And this is an important concept that all creative people do. They visualize, they work, they mold ideas both in and out of the workspace before they put out their great masterpiece. And this concept of putting out ideas repeatedly and productively and not waiting for that perfect idea to emerge is extremely important in creative cognition. The second major idea about creativity is that creative people tend to be open to new ideas, yes, but they also tend to be disagreeable, which is a bit of a surprise. And the prototypical example of this is Steve Jobs. This comes from research from Greg Feist, who his quote is, "In general, creative people are more open to new experiences, less conventional, and less conscientious, more self-confident, self-accepting, driven, ambitious, dominant, hostile, and impulsive." And Steve Jobs, again, is a prototypical example of this. Being able to create new ideas and put them out into the world where people don't want to hear all your great new ideas is kind of a difficult thing to do. We are designed to conform with each other. We are designed to get along, to not conflict. And the creative process is one that really forces you to put out ideas that inherently conflict with the status quo. This is extremely important concept. And teaching children to be comfortable with pushing ideas in spite of the fact that they want to go along, to get along, to be liked by other people is a very big wall to climb. So getting comfortable with that idea that you don't have to be a jerk, but you can be a bit disagreeable in this process and persistent and ambitious and dominant sometimes to push out a great idea is important. And that's one of the reasons that a few of these kids are going to be here this afternoon instead of all 250, I would assume. And the town crier is an example of that, someone who is going to step up on the table and push that idea forward and be that person that leads the crowd instead of follows the crowd. The third major idea, they are very good at one thing. Now, Malcolm Gladwell talks about this in the 10,000 hours or 10-year rule. And this goes against the conventional wisdom that you have to be good at all things, that you have to be a polymath, a Da Vinci type of figure where you must be good at all things. And this really is not true of highly creative people. They might have or dabble in violin or musical instruments as well as being a scientist, but you really have to have an expertise in one area in order to be extremely productive and creative in that area. You have to have a certain expertise in that area in order to be able to produce new ideas in that area. Very important. And that 10,000 years or 10,000 hours or 10 years is an average. Some people who have a particular aptitude in that area might take less, and people who have less of an aptitude might take more time to develop that expertise. They are highly driven to succeed. This kid is an example of that success because you too can own this face of pure accomplishment. Again, this gets back to persistence, perseverance, determination. Creative people really have that quality, and that is something that I think is lacking in some of the delicate flowers that we have in our classroom at this point in time. It's really hard to teach that quality to children that are very averse to being judged and to being found wanting at times, that their ideas might not be that perfect idea. This is extremely important to give opportunities to get good feedback and productive feedback. This growth mindset that we talk about, where kids can get appropriate feedback for their effort and determination in pursuing a goal as opposed to the quality of the product. This is very important. Finally, they know how and when to relax. It's not just all about homework and all about stuffing ideas into your brain. There has to be some downtime in order for creative people to put ideas together, for those ideas to run into each other in novel and useful ways, which is the very definition of creativity. And that downtime is particularly important for creative cognition. So that relaxation time, and there's lots of ways that creative people do this, and we can talk about that, whether it's a long walk in the woods or a warm bath or staring out the window. There's lots of ways that creative people and tricks and techniques that creative people have to do that relaxation thing that allows their mind to wander in such a way that they can visualize worlds that might exist as opposed to the worlds that do exist. And that relaxation time is an incredibly important time as opposed to just the daydreaming that it looks like to people from the outside. Another important concept is that I think this creative thing that we do as humans has analogs in the animal world, that it's an evolutionarily derived process that is important to our very survival. It's a reasoning process that allows us to adapt and succeed out in the world. When you think about, I was thinking about a way to allow you to envision this process. So if you all close your eyes, okay, and you imagine that you woke up this morning and you looked out your window. Oh, first of all, the power's off in your room or your house or wherever you woke up this morning. And you look out the window and there's no cars on the road, and there's no planes up in the sky, and everything's quiet. And you're wondering, what the hell's going on? And you can't check the internet because it's down. You can't check the TV because it's down. What do? How do you find out what happened? Is the power down? Was there a terrorist attack? What is going on? How are you going to go about solving this particular problem? You have to start thinking about it. You have to start doing mental simulations. What could have happened? There's a snowstorm going on. Maybe a power line went down. But why aren't people driving around? That's weird. So this is a highly adaptive process. Go ahead and open your eyes. I'm not going to force you to do an exercise, but think about that mental space that you were in. This is a highly adaptive process of problem solving where you have to hypothesize, you have to envision different scenarios, you have to envision what you might do next before you go out and do it out in the world. Are you going to go outside? Not if it's really dangerous. Are you going to try to talk to the people next door? Is that the first thing to do? Possibly. See if they know any information. How would you gather and acquire information when you can't do it in the usual way? Very different type of problem solving. It's a very adaptive type of problem solving. If there was something highly dangerous that happened, it could possibly save your life. So this is the type of reasoning and problem solving where we do hypothesizing before we have all of the information at our disposal. This is called abductive reasoning. It's not deductive reasoning, where we do cause-effect relationships, where everything is known to us beforehand, and the relationships are well in hand. If the planes are out of the sky, it must mean that there was a terrorist attack. We know that from 9/11, for example. It must mean that there's something really serious going on. If the power's off, it could be something very simple, like just the power line's down. And you can look down the street and see, oh, the street lights are on down there. It must be a local thing because the power's just off in my building. It's not on in my room. So you can do some sort of problem solving like that. But this is a very adaptive problem solving. Getting back to my first point, dolphins do this type of thing. So you have this example of female bottlenose dolphins in Shark Bay. They use basket sponges to protect their beaks while foraging for fish in sandy beds. Now that's just females that do, they're primarily females that do this. The males aren't interested in this for some reason that we don't fully understand. But they just discovered that females will teach other dolphins about how to do this. The sandy bottom is very gritty on the very sensitive beaks of these dolphins, and they use their beaks to flush these fish out of the sandy bottoms. And so they use these sponges to flush out the fish while still protecting their beaks. This is very interesting tool use by dolphins. This is very adaptive problem solving. And then, of course, dolphins play as well. I'm going to turn this down a little. This is a bubble that the dolphin has created out of its own blowhole. And there's another example, so you can see it pushes this bubble out and it's spinning it around and playing with this ring bubble. If another dolphin comes and tries to play with its bubble, it will pop it. That's my bubble. But it's just fascinating play-like behavior see how it created that ring, just fascinating play-like behavior of these dolphins, keeping themselves, watch them produce this ring out of its blowhole and then spin it around and play with it. It's just fascinating behavior that we're seeing in these dolphins playing. Like they're taunting each other or communicating with each other. We don't know quite what's going on, but this is a very adaptive problem-solving type of activity that's going on that we don't fully understand. So, what is creativity? It's the production of something novel and useful. This is the definition of creativity. And this is an important dichotomy of creativity. Novelty alone is not enough. It can be silly. It can be something funny. It can be something entertaining. But mere novelty for novelty alone is not enough to produce creativity. And utility has been done to death. It's boring. It's not enough as well to produce creativity. So you have to have that intersection of novelty and usefulness in order to have something that's creative. It's this balance between novelty and creativity that is extraordinarily in sync with this process. And I think the brain is taking this metaphor appropriately. There's this balancing in the brain between adaptive, deductive reasoning and problem solving, as well as this abductive, playful type of reasoning and problem solving that goes on in creative cognition as well. Now, there are a number of myths that we have to dispel about creativity that I want to take you with. One of the main neuromythologies, if you will, about creativity is that you have to be crazy in order to be creative, truly creative. And there's any number of individuals who are brilliant examples, the first being Vincent van Gogh, who cut off his ear when he was in the throes of probably bipolar disorder towards the end of his life. Brilliant painter. I like Georgia O'Keeffe, who is a local artist to New Mexico, who suffered from severe bouts of depression, another major mental illness that is often associated with the expression of high levels of creativity. And then John Nash, who some of you may know is a brilliant Nobel Prize-winning economist whose life was chronicled in A Beautiful Mind, a movie that most of you probably saw. Probably had schizophrenia, a psychotic disorder certainly. But for every number of examples of individuals that have these mental illnesses, there are an equal or greater number of individuals. There's not a whiff of mental illness at all. So while it's nice to think of the Van Goghs and the John Nashes of the world who have the presence of mental illness and high levels of creativity, you have the Da Vinci's, the Ben Franklins, the Madame Curies, who did not have any a level of mental illness. It is not inevitable that you have to be crazy or act crazy. There might be a looseness of associations and a looseness of the frontal lobe organization that's involved in creative cognition, but it's not inevitably true that you have to be crazy or act crazy in order to be creative. The second major neuromythology is that you have to be some sort of frickin' genius in order to be creative and high levels of intelligence. The prototypical example of this is Albert Einstein, the genius of the 20th century, who in 1905, I can't remember which year, had his golden year where he produced a number of papers, one of which led to him winning the Nobel Prize. But for every example of the high levels of intelligence that are associated with creative cognition, we have other examples of individuals who are lower in intelligence, and we have brains that are commensurately a good example of lower levels of intelligence, let's say, associated with high levels of creativity. It's not inevitably true that you have to be really high levels of intelligence to be truly creative. And there's actually good research that shows there might be a threshold of intelligence that facilitates creativity, the acquisition of that knowledge base that's important to put things into your head. But if you get above that level of intelligence, it actually might devolve into coming to that correct answer too quickly, as opposed to thinking up new types of answers. So there's really important and interesting literature looking at that threshold of intelligence and creativity. Finally, the most pernicious myth of all involves this notion of creativity living in the right hemisphere of the brain. How many people have heard of this one? I'm sure most of you know that creativity lives in this side of your head or something like that. This comes from research from two brilliant scientists, Gazzaniga, a neuroscientist who's still alive, and Sperry, a neurosurgeon. And what they were doing is Sperry, the neurosurgeon, was doing surgery to sever the corpus callosum, this white matter region of the brain that connects the two hemispheres. This was used to help with intractable epilepsy. So patients that had grand mal seizures, and the seizure would start in one area of the brain and propagate to other regions of the brain, you'd sever the corpus callosum. It created a dead stop so that the seizure could not propagate to the other hemisphere. Therefore, you couldn't have grand mal seizures. Now, Gazzaniga would do testing, like a neuropsychologist would do testing on these patients, and found that the two hemispheres, left and right, communicated somewhat differently from each other. Left hemisphere was more logical and linear and analytical, and the right hemisphere was more about wishes and rainbows and unicorns and stuff like that. So there was some sort of actual indication that the two hemispheres functioned rather differently. This got taken up in the popular press like wildfire, that creativity lived in the right hemisphere because it was more nonlinear and synthetic, and some artistic abilities lived, if you will, or were localized in the right hemisphere. This really became propagated that creativity was in the right hemisphere. I guarantee you that if you had no left hemisphere, or you had significant damage to your left hemisphere, you would not be creative as well. So that is definitely wrong. This left brain, right brain stuff is definitely wrong. We need to dispel these myths. These are the three major myths. There's more that I'm sure I can help you dispel if you want to talk later. So, what do we know about creativity? Now, we have these very old concepts about creativity, and I'm going to walk you through some major stages using these old concepts, but I want to help you understand that we're trying to modify some of these old concepts that come to us from the 1800s, actually, about how these different stages of creativity work. And Henri Poincaré was a famous mathematician and philosopher who gave us these four major stages, actually five in his case, that were later trimmed to four, about different stages of creative cognition. Because creativity is not just one thing, but several different things that we want to try to understand as scientists try to disentangle. And we're using these different stages as metaphors as we try to modify them and pull them together for scientific purpose. So I'm using these stages as a metaphor, but they're probably incorrect, like the neuromythologies that I just walked you through. Preparation is the first stage. Now remember, we talked about the 10,000 hours or the 10 years. You have to have some things in your brain to put them together in novel and useful ways. The artist has to understand something about color and tone and hue. The scientist has to understand something about the scientific method, and if you're a neuroscientist, something about the brain. Teacher has to understand something about teaching methods and pedagogy. So you have to prepare for that in order to be able to be creative in that area, and that takes some time. Again, this polymath concept of knowing lots of different things may be incorrect. You have to know one thing certainly very well, and you can dabble in other things, and that's probably good for the creative process to have a wide range of interests, but you have to be very good at one thing. That skill acquisition part is extremely important. By the way, this is my brain, just to prove first of all that I do have a brain, and to show you some of the techniques. I'll be showing you some of the techniques that we use in our laboratory. This allows us to look at cortical mantle and the cortical thickness of the individual brain. So this is my brain, popped out of my head. My cerebellum is not green.
What color is it?
It's gray, like everything else. It's kind of gray. Incubation is the second major stage of creativity. That's that kind of downtime, that time where you are thinking about an idea, where you are cogitating, you are percolating an idea. Divergent thinking are some of the tests that we use to get at this incubation. This is my white matter now, so we're looking at white matter tracks going through my corpus callosum. It looks kind of like a really wild mohawk. And I'm going to be articulating a seed that looks at different regions of the white matter. Some are more localized and some are more distributed throughout the brain. And hypofrontality is an interesting concept in this incubation period. You need to downregulate that error checker in your frontal lobes. You need to be a little disinhibited. Not so disinhibited that you're going to take your clothes off and run around the room, but a little disinhibited so that you can come up with new ideas. So your error checker is off just a little bit, and that you're not devolving to the right answer too quickly, that you're looking just a little bit further and you're thinking about things just a little bit longer in order to come up with something new and useful. So this is what a divergent thinking task looks like. We give someone a common item like a brick, and we ask them to name all the different ways they can think of to use a brick. So you get answers like a paperweight, a doorstop, a mock coffin at a Barbie funeral. Now that one's different than the rest. To throw through a window, to use as a weapon to hit my sister on the head with. So, these are different types of answers. Some are, weight kind of things. Some are decorative kind of things. Most are weapons, it looks like, in this individual. So you have different qualities, and you can score them on fluency, the actual number of items, because remember, more items, more productivity usually leads to more original ideas. We know that. So that the people that produce more volume of items end up tripping over one, like this person that had 3, 4, 5, 6 items, but has this mock coffin thrown in there as kind of like a weird throwaway item, but it's actually kind of interesting. Let's talk more about that one, the psychologist would say. Another type of item that we use. What if people could change back and forth from boy to girl whenever they wanted to? What would be the implication for that? Write about that. And so people will write about, or what if people could turn invisible whenever they wanted to? What would be the implication of that? This is like the exercise that I had you close your eyes and think about what would be the implication if people could turn invisible whenever they wanted to. And so, one answer, shy people could have sex and a little more. So, there are lots of funny answers that you get with people that, college students mostly, that we test, really funny answers that you get with these types of questions. Illumination, that aha moment that people talk about, is the third stage that we talk about commonly in this creative process. And this is that aha moment, the Eureka moment, Archimedes in the bathtub discovering how to measure the amount of gold in a crown through dispersion of water in a bathtub. It's moving from the unconscious to the conscious process and being able to pull that idea out of that mental workspace, that visualization think pad that you have going on in your mind's eye, out into the real world, into the wet world where you're going to try something out in real time. This is where you are pulling an idea into real space. So this is the type of task that we use for insight tasks. And again, they're not very good tasks, but we give people 3 words and we ask you to think of one word that will tie them all together into compound words. So it's like lick, mind, shaker. Yeah, so I heard it. Does anyone else have it? Salt, yeah. So salt lick, salt mind, salt shaker. That's the one word that ties them all together into compound words. And you don't think about this through a process of elimination or deductive reasoning process. It just kind of pops into your head, right? It's like you didn't it's like mine shaft, and it's like you don't just try to go through them and figure it out. It's just there all of a sudden, like a moment of insight. So that's what we use for that. Now this is designed to show you the complexity of the brain processing that we're looking at. This is a very different technique that we use, and I'll show you this again. This is magnetoencephalography. It's like an EEG, but it's looking at magnetic impulses that go through your brain. Now let me explain this to you. We're only looking at 400 milliseconds. That's 4/10 of a second. And this is looking at the back of the brain, the occipital cortex, and we're going to be looking at just an image flashing on a screen. It takes about 100 milliseconds for the image to get from your eyeball to the back of your head. And this is what the image looks like on your, what the processing looks like in your occipital cortex, to show you the complexity. When you read in the newspaper about this area lights up when you see a unicorn, or you think about your grandmother, for example, and this area lights up when you think about romantic love, it's a lot more complicated than that. And this is the area of activation, just seeing an image on the screen at 100 milliseconds. See that explosion of activity in the occipital cortex. Finally, the verification. You have to see if your idea is going to work out in the world. Will it work? Are people going to like it? Is it going to fit? can I push and persist in such a way that people will accept this idea? So you have to go back to ground truth. Again, this is my brain. This is a standard MRI process. This is the old technology that you go back to see if it is consistent with what you know and what you can know. So this is retaining that idea. Things that are also important to the verification process is openness to new experience, grit and determination. You've heard a lot about that. Angela Duckworth's work in grit is important to this process. But that is an important process of creativity, is that verification process to see if your idea will stand the test of time. Now, the neuroscience of creativity, I'm not going to spend a lot of time on what we've found, but we've done several bits of research where we've looked at different bits of brain and different modalities. One looked at brain chemistry. In 2009, we looked at, this is all using a standard MRI machine, and we looked at the chemicals in the brain. And this is all done with college subjects, so you have to use all the caveats about whether they're normal or not, but these are all normal college students. And large samples, 50, 60, 70, now we're up to 250 subjects that we're doing our research in. And we found something very interesting, that there was a region in the frontal lobe, the anterior cingulate cortex, which is a region that kind of gates information flow in the frontal lobe. And we found lower biochemistry that is usually associated with integrity of the frontal lobe, associated with higher creative cognition in this sample. It was really kind of confusing. We went on and we looked at cortical thickness, again, the gray matter, the processing units on the surface of the brain, the cell bodies that are like your computers that are on the surface of the cerebral cortex. And we asked the question, where in the brain is creative achievement associated with cortical thickness? And we found an area in the frontal lobe. This brain is expanded a little bit so we can see down into all the peaks and valleys. And we found cortical thinning was associated with higher creative achievement in the frontal lobe. It was like disinhibiting, like less controls or fewer brakes were on the system in the frontal lobe, associated with higher creative achievement in these subjects. Finally, we looked at the white matter of the brain. This is an axial view slicing down through the top of the brain, and we wanted to look at all the wires, the white matter wires that connect up the different processing modules, and ask the same question, where in the white matter connectivity was creativity associated with white matter fidelity? Found a region in the frontal lobe where white matter fidelity was associated with creativity, but again, it was an inverse direction. Lower white matter fidelity, like a spreading of white matter tracks in all directions, higher spreading was associated with higher creativity. This is a very consistent picture showing us that lower measures of fidelity, that as we usually understand, these are all normal college students, very healthy. We made sure they didn't have any brain damage that we knew of or that they would admit to in our samples. So very normal brains like yours and mine, but slightly lower measures of what we consider to be integrity or fidelity or strength, if you will, of the brain associated with higher levels of creativity. When we looked at all of the structural measures in a subsequent paper, we found several regions of the brain, both in our studies and in other studies, people that looked at people with actual brain damage and found that if you took out a chunk of brain here in the anterior temporal lobe, people would perform better on these divergent thinking tests. Or had a lesion in the parietal lobe here, people perform better on some of these creativity tests. So all these regions where you see blue are studies, other than ours, where you have lower measures of brain integrity or even lesions of the brain associated with higher levels of creativity. There were some regions in red where you saw higher levels of fidelity or integrity or strength associated with higher levels of creativity. And these conform generally to two different networks of the brain. Finally, a study came around in about 2013 that really sealed the deal for me. I had a moment of insight, an aha moment. They did this study in rap artists, and they were doing rap in the scanner. They were doing improvisational rap in the scanner, and they were finding that these artists were downregulating certain networks of their brain and upregulating other networks of their brain while they were doing this improvisational task. And it conformed to these regions that we were seeing in our structural studies. They were downregulating the intelligence, kind of cognitive control regions of the brain on the outside, rind of the brain, if you will, and upregulating these medial portions of the brain on the inside of the brain. It's called the default mode network, which I'll get to in a moment, on the inside of the brain to facilitate this flow state, this improvisational state, this creativity on the fly associated with rap. Here's an example of one of the artists and authors of the study.
La 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 la. What's all the racket? I'm sorry, it was me, sir. Riding down Slauson, bumping 97 Weezer. Don't know all the lyrics, but I hit the keywords. All my favorite tunes are from when phones had receivers. Got a lady, and I'm on my way to meet her. Gonna form a union like a local group of Teamsters. Get your tweezers, doing by your research. Hot enough to press a graphic image to a t-shirt.
So they can contrast just talking or repeating a rap lyric as opposed to improvising that. So it's a really nice study when you can contrast, and they've done this with pianos too, Charles Limb, where you can just copy a piano riff in the scanner while doing that with improvising in the scanner. You can really see that creative process on the fly, and you can see this interplay, this handoff between the cognitive control network and the default mode network of the brain as they're handing off these tasks to each other, both involved in creativity, but different parts of the creative process. So this really was a major insight for me thinking about creative cognition. You do have this internal thought network, and the default mode network is very hot in cognitive neuroscience right now. And it's that thing you do when you close your eyes and you think about your relationships and how you're going to talk to that difficult employee or that difficult child in your classroom. What am I going to say to him or her? You're simulating what that conversation is going to look like. You're visualizing that difficult conversation. Nah, that's not going to be quite right. What if I said this? Or you're thinking about your grocery list and if you need to add something. Or you're reading a good novel and you're in that mental space where you're in that time and place and you're with those people and you can actually smell the coffee that they're brewing in that story. I mean, you're actually there. That visualized space is the default mode network where you are in that visual workspace that we all have. It allows you to do situation-specific improvisation. It's about induction, abduction. It's about this hypothesis testing, and it's about if you don't know what's going on, you can simulate in your mind what you think might be going on and do that prospection. It's about preparation and incubation in the stages, the various stages of creative cognition. And if you look at the study that we did with structural imaging studies and the specific regions of the default mode network, I will tell you that there is significant overlap. That's what all these arrows mean. Look, they're the same. There's significant overlap between the default mode network and the regions that we found in our study. Now this is contrast to the wet world of reality where you have special purpose problem solving. This is the intelligence network of the brain, cognitive control, cause-effect relationships, special purpose problem solving. You know what to do. 95% of the time in the world, you know what you're supposed to do. You know if this happens, you're supposed to do that. Rule-based cognitive system, deductive reasoning, cognition in the external world. This is about illumination, verification. It's important to creative cognition. It's the other part of creative cognition. But there's this handoff between the internal thought space and the external thought space. And both of them are engaged in this creative process. So what can you do to increase your creativity? In terms of the internal thought process, this blind variation, this putting out a lot of ideas, you need to find your away time. I think this is the most important thing for that internal thought space. The warm bath, the long walk, meditation, exercise, napping, drinking, all these things have been used to facilitate that down-regulation of frontal control systems, this downtime, this away time. I like to mow the lawn. That's my favorite thing to do. It's engaged motor activity, so I'm doing something with my body, but my mind can run free. And I keep putting in more grass on my property, and my wife thinks I'm crazy, but I like to mow the lawn. It's a good away time for me. There's lots of noise. All the world is drowned out. I'm engaged in physical activity, and I can think about lots of different things, just going in a row and going back and forth in a row. And it takes me about 45 minutes to mow the lawn. It's really good away time for me. That is my good space. I do it about once a week in the summer. And in the wintertime, I look out the window. My staff comes and it's like, what are you doing? It's like, looking out the window. And it's important time for me to look out the window. I have to have a window to look out. I found out when I worked in an office that didn't have a window, it drove me crazy. I can't just be looking at the computer and do this thing that I need to do. I need to look out a window. It doesn't make a difference what I'm looking at. Oh, and no anything. iPads, iPhones, all this stuff, it's a distraction. I think we need to get away from that too, and it's becoming increasingly difficult to do that, to get away from that I stuff. That's about knowledge acquisition. It's important for the creative process to have those I things, but if you're getting away from that to do that incubation thing, you need to get away from that at least temporarily. And I think with kids, I'm hearing about 2 and 3 and 4 hours of homework. That's all about knowledge acquisition. When are they getting away from this in order to do this incubation thing? I think that's important to be able to have that time to put ideas together in novel and useful ways in order to be always acquiring knowledge. There has to be putting ideas together on their own as well and learning how to do that process. In terms of external thought, selective retention, be open to new experience. Travel is one of the best way to do that. And this isn't traveling overseas, but traveling outside of your bubble. We all enjoy this academic bubble that we live in, and getting out and meeting different kinds of people and new types of experiences is critically important to expanding your horizons and getting out of your little bubble of comfort that you like to live in. It's one of the reasons that I go and do these types of things. I get to meet different kinds of people sometimes. It's mostly the same bubble, but sometimes I get to meet different kinds of people and have different types of experiences that force me to think in different ways. Read, I was talking about that mental workspace, and the reading, especially fiction, exercises your brain in that way that allows you to do that visualization thing, to be able to simulate yourself in that time and space, in that mental world of someone else's imagining. Be critical and rational. Very important to be able to down select best ideas as opposed to be accepting of all ideas. It's important to be able to down select as you down selected the children that will be coming here this afternoon. Finally, persistence and grit and determination, extremely important. It's hard to teach that in yourself and in children, but this is a very important concept for successful creativity, is to have people remain determined in the face of opposition. Every single paper I've written now, I've published 80 papers in the scientific literature. Every single one of them were rejected first time around. Every single one. I've never had a paper accepted the first time. Every single one came back with red marks basically all over them saying, this idea is horrible, your spelling sucks, your grammar's poor, every single one of them. But you have to persist and say, no, this idea deserves to be out in the scientific literature. And put out a lot of ideas, being able to put out a large number of ideas. Even though I put out 80 individual ideas, they're not all good ideas. I'm not going to tell you that. But some of them are really good ideas. Some of them will stand the test of time, and some of them are used by other scientists, some of those ideas. And if you put out a lot of ideas, some of them will be hits, a lot of them will be misses, but you can't be the one-hit wonder. Thank you for your attention.